Yeah, another example, classes 10A and 10B have 12 and 18 students respectively. It means there are 12 students in 10A and 18 students in 10B. And a basketball team of 5 players will be formed by choosing 2 students from 10A, and 3 students from 10B. It means from 12 students we choose 2 of them, and from 18 students we choose 3 of them. How many different teams can be formed? In here we have again a combination, but in here we have a case which we have 2 choices from 10A and 10B. So we should use multiplication counting principle also, or multiplication method also, as in previous example. So let's find them. Combination of, first of all, from 10A, combination of 2 from 12 times combination of 3 from 18. 3 from 18. Yeah, let me clean this part. So if we calculate them, we can write as 12 factorial, 12 minus 2 is 10 factorial, times 2 factorial, times 18 factorial over 18 minus 3, 15 factorial, times 3 factorial, and it will be equal to 53,856. So how many different ways or there which the team can be formed? There are 53,856 different cases or ways to choose or to form this team. The next example, how many 3-digit numbers ABC? The order is given. First, in unit digit we have C, and 10 digits we have B, and in 100 digits we have A. So we don't have any other order. How many 3-digit numbers ABC can we write which satisfy the condition C is less than B and less than A? As we have only one order ABC, and there is also another condition between B, C and A, or ABC, which C is less than B and B is less than A, so we do not use permutation. Why? Because we have only one order. So in this case, we can find the number of these 3-digit numbers using combination. Total we have 10 digits in here. From here 10 digit, and we want to choose 3 of them from these 10 digits. So combination of 3 from 10, and it's equal to combination of 3 from 10 factorial over 3 minus 10 minus 3 is 7 factorial times 3 factorial, and it's equal to 10 times 9 times 8 times 7 factorial over 7 factorial times 3 times 2 times 1. 7 and 7 factorial cancelled. 3 with 9 can be cancelled as 3, and 2 with 8 can cancel as or simplify as 4. So 4 times 3, 12, 12 times 10, 120. So how many 3-digit numbers by the order of ABC, which C is less than B and B is less than A, can be formed by these 10 digits, 0 from 0 to 9? There are 120 different 3-digit numbers. Another example, a watchmaker has 7 different jewels. It means the total number of jewels are 7. He wants to choose 4 of them. So combination of 4 from 7 to decorate the quarters 3, 6, 9 and 12 on the face of a clock. How many different decorations are possible? In here we have combinations, but as it's mentioned that he want to decorate it in quartets 3, 6, 9 and 12, so there's an arrangement between them also, but it's not a circular arrangement. Why it's not a circular arrangement? Because the position of 3, 6, 9 and 10, 12 are mentioned in here. You cannot change the position of 3 with 6, 6 with 9, or 9 with 12, or so on. So therefore the permutation is like linear permutation. So let's find them. Again, combination of 4 from 7, 4 from 7 times, as we have 4 elements or 4 different decorations, or arrange bit. So times 4 factorial, and it's equal to 7 factorial over 7 minus 4 is 3 factorial times 4 factorial and 4 factorial cancelled, and if we calculate them we will get 840 different decorations. So how many different decorations do we have in here? We have 840 different decorations for this case, which we have 7 jewels and we want to create the quarters. You remember that the number of odd element subsets of a set of n elements is equal to the number of n minus r element subsets. It means if the total number of a set, I want to show it by an example. If the total number of the elements in a set is 6, so 2 element subsets of these 6 elements is equal to 6 minus 2, which is 4 element. 4 element subsets of this set is also, the number of the sets are also equal to each other. Why? As you see in here, it's shown. So let's calculate them. If we want to calculate the combination of r chosen from n, it will be n factorial over n minus r factorial times r factorial. And to the right side, we have a combination of n minus r from n. So we can also calculate them as n factorial over n minus r factorial times n minus r factorial. And let's simplify it. It will be n minus n, so it's n minus n plus r. N minus n will be cancelled. In here will be r will be left. So n factorial over r factorial times n minus r factorial is left. N minus r factorial is left. So as you see in here, we have in both sides we have n factorial over r factorial times n minus r factorial. As you see, both sides are equal to each other. So we can say that r element subset of a set with n elements is equal to the number of n minus r element subsets of a set with n elements. For example, in here, the example says that the number of 3 element subsets of a set is equal to the number of 6 element subsets of the set. It means in here, if we say that combination of n 3 from n, is equal to combination of n from n minus 3, which is combination of 6 from n at the same time. It's mentioned. So in here, if the total number is n, so n minus 3 will be 6. If we calculate n minus 10 as 6, so in here n will be equal to 9. But the question says that find the number of 7 element subsets of the set. As we know in here we found the total number of the elements as 9. So we can find the 7 element subsets. Combination of 7 from 9, and it's equal to 9 factorial over 9 minus 7 factorial times 7 factorial, which is equal to 9 times 8 times 7 factorial, over 2 factorial times 7 factorial. 7 factorial are cancelled. 2 factorial is 2, and if we simplify it with 8, it will be equal to 9 times 4, which will become 4. 9 times 4 is equal to 36. So how many 7 element subsets are there? 36 7 element subsets are there for this set with 9 elements. And the last example of combination or usage of combination in geometry, we can also use it in geometry. Derive a formula for finding the number of diagonals in a convex polygons with n sides. you know, diagonal is a line which connect or join two non-adjacent vertex of a polygon. It means if you have a polygon like this, look at here, two non-adjacent. This one is one diagonal of this polygon. This one is another diagonal of this polygon. But if a line join two adjacent vertex of polygon, it's not diagonal, it's a side of that polygon. So in here, if the total number of sides of a polygon is n, so it means that there are n vertices in this polygon. The total number of vertices are n. But what do we want in here? We want two element subset, or two elements with the subsets which have two elements from these n elements. So combination of 2 from n is in here, but we also have that lines which connect the two adjacent sides, which there are n sides here, so we should subtract them. It means this is the number of diagonals, and this one is n is the number of sides of the polygon. We should subtract them. Why? Because they also join the two vertex of the polygons. So let's calculate them, evaluate them. N factorial over n minus 2 factorial times 2 factorial minus n. Simplify it, so we can write n factorial as n times n minus 1 times n minus 2 factorial over n minus 2 factorial times 2 factorial is 2 minus n. N minus 2 factorial, n minus 2 factorial are cancelled or simplified. So let's continue. What's left in here? In here, n times n minus 1 over 2 minus n is left. So let's calculate again, or let's go on. N square minus n minus 2n. If we take 2 as common denominator in here, over 2 will be left in here. So let's again subtract or add negative n with negative 2n. It will be n square minus 3n over 2. If we take n as common factor in here, n times n minus 3 over 2 will be the number of diagonals for this polygon with n sides. Check yourself. 11 is your homework for this subject, I mean combination. You will solve it. If you have any question about this subject, you can contact with us from school WhatsApp number, and we will respond you. Thank you.